Okay, so in the previous part of this problem, we saw that the equation for the motion of mass is y of t is equal to 2 cosine of 2t minus 1/2 times the sine of 2t. So that is our equation of motion that's requested. The next thing to do is find the angular frequency. So the formula for angular frequency is going to be omega. Let's see here, make it a little better than that. Omega is equal to the square root of k over m. So that's the square root of 1 over 0.25, which is the square root of 4, which is just 2. And the units for this are always going to be in the radians per second. So 2 radians per second is the angular frequency. Next up, we want to find the amplitude. So that formula is always going to be the square root of the sum of the squares of the two coefficients c1 and c2. So that's the square root of 2 squared plus negative 1/2 squared. So that's the square root of 4 plus 1/4, which is the square root of 17/4, or the square root of 17 over 2. And in this case, these are going to be meters because that's the unit of measure of distance in this problem. Okay, so now the last thing for us to do is find the natural frequency of the oscillation, and that is just our value of omega divided by 2 pi. So we found omega to be equal to 2 divided by 2 pi is equal to just 1 over pi. And again, that is referred to as our natural frequency of our oscillation. And then the next thing we'll do is actually show you on the notes, if you will, the graph of this, which will show us the amplitude, the frequency, and the natural frequency of oscillation.